All right, so we are lesson, let's just do 2-5. So chapter 2, lesson 5. And actually, we're getting close to the end of this chapter. This is the last set of a lesson, actually, for this chapter, which means when we come back from break, we'll review this topic and then do review of the chapter. And you'll be taking your chapter 2 test Friday when we come back from Thanksgiving. Okay? So today we're going to talk about solving multi-step equations. And today's date is 11/20/15. There we go. Joshua's getting... We're not at break yet. Let's get through it. So we've talked about solving one-step equations where we only did one operation to get the answer. And then we talked about two-step equations where we had to do two different operations to solve for the variable. Then we talked about having variables on both sides, and then that complicated things. And sometimes somebody dingers needs to go off. Oh, Mr. H. So we would have to do two steps generally to get variables on one side, constants on the other, and then a third step to get the coefficient away from the variable. So it took us a little bit more. Now this one's going to bring in everything. Okay? So solving multi-step equations, there is a protocol, and your card is your protocol. So what I'm going to do is write out the steps very briefly that your card has. So first, we're going to distribute. And as you noticed, as you've been using the card, we didn't need to distribute up until maybe this point. Okay? So we distribute. That's our number one job, is to distribute. Okay? Number two job, combine like terms on a side. So combining like terms means I can only look at one side of my equation, and I can only do any math that's available on that one side. I don't do inverse operations. I do exactly what it tells me to do there. Okay? On the other side, I do the same thing if I can. So, combine like terms. 3, that's when I'm going to use inverse operations. And only adding and subtracting is available to get, and I'm going to say this very generally, constants together. We talked about specifically on the card, it says take them to the right, but we've been talking about you do have flexibility whether you take them to the right or you take them to the left. But whatever side you determine to put the constants on, the variables need to go on the opposite side of the equals. So I'm going to just give you some more general directions. So use inverse operation, adding or subtracting to get constants together. It's the only way to get across the equal sign is to do the inverse operations. And then we're going to use inverse operations. Again, adding or subtracting to get variables together. So I'm going to write a little note off to the side regarding these two. They must be on opposite sides of the equal sign. You cannot bring everything to one side and have equal 0. You're not done. You can only have one thing, constants, let's say, on one side of the equals, variables on the other side. We have the freedom, which side those are. Then we talked about we're going to use inverse operations again, but now what we're trying to get rid of is the coefficient. The only math that happens, the coefficient is either being multiplied by the variable or being divided with the variable, so the inverses would be either multiplication or division. To remove or get rid of the coefficient. And in other words, it leaves the variable alone. Our sixth step on our card, you should check your solution using substitution. Okay. And again, the format is variable equals answer. You must have a variable in your answer. Okay? Oh, Brandon. Okay, so let's do some practice problems and see how they go. Our directions, and you can do this all on one side. I don't think you're going to need, unless you want to, unless you feel like you're not going to have room. Examples are going to ask you to solve. Embedded in that is, you better show me all your work.
Is it on the other side?
You can do the other side, or you can do it on the same side if you want to. So we have 15 times the quantity, 20 plus D, equals 420. All right, so according to our equation card, what's the first thing we're supposed to deal with?
15 times 20.
Okay, so in general, distributive, right? So absolutely 15 times 20 is going to be the first one. So 15 times 2 is 30, and then there's an extra 0, so I get 300. Notice I drew my link, and I wrote the product, okay? Draw my link, 15 times D is going to be a positive 15D. And then the rest of the equation equals 420. Okay, do I have like terms on this side?
No.
No, so I can't combine. Do I have, oh, that's what I wanted. Do I have like terms on this side?
No.
No, so I have nothing to combine. So now I'm going to start doing inverse operations. Well, the good news is variables are already together. I only had one group of variables. So it's the constants I'm going to get rid of. So how do I get rid of 300 from the left? Yeah. And remember, we're doing a property of equality, so we're subtracting 300 from both sides of the equals to keep the balance. If I only took it away from one side, your balance would go like this. If I take it from the other side, then it balances out. Okay? So then that gives us 15D equals 120. Okay? So now we're all the way to step 5, right? I need to get the D alone, so I need to get rid of the coefficient, which is the 15. So what math am I going to do to get that D to go away? Yeah, opposite of multiplying or inverse of multiplying is dividing. So I get D equals, and then let's see, 15 is going to go in something like 8 times? Yeah, 8 times evenly. And then you can always do a quick check. Is 15 times the quantity 20 plus 8 equal to 420? So order of operation says I can add 20 plus 8, so I'm going to do that. Now I don't know what 15 times 28 is, so I'm just going to do it down here. I get 140, placeholder, 8, 2, I get 0, 12, 420. So I get 420 equals 420, which says, yep, D equals 8 is your answer. Okay? The boss is speaking out there, that's for sure. All right, so I want to give you another one. Negative 3 times the quantity 9 plus x equals 33. So what do you think is the potential trouble with this problem? What do you think is going to be where there might be room for error? Not with the x, Danielle. Not with the x. Oh, this is supposed to be a plus, by the way. Where do you think people are going to make mistakes if on this problem? I saw you mouth it there, Ashlyn. The signs. So it's super important that you are paying attention to your signs. Okay. So yes, we have parentheses. So yes, we're going to distribute. So a negative times a positive. That's the dialogue I have as I worry about signs first. A negative times a positive is a negative. And then 3 times 9 is 27. A negative times a positive is a negative. And then 3 times x is 3x. Okay. So again, I have all my variables are in one spot. That's good. So it's my constants I'm going to need to move. So what's going to be the inverse operation?
Plus 27.
Yeah, inverse of subtracting 27 or negative 27 is adding 27. Now, the second place for error was, first place was distributing the negative. The second is paying attention to the negative. What I'm left with on this side is not 3x, but a negative 3x. That sign, remember, is attached to that number. On this side, when I add, I get 60. Now I have one more place to make a mistake because I still have signs, and that's what I have to watch out for. So the opposite of multiplying by negative 3 is dividing by negative 3. So that gives me x, and then signs are different, so I'm going to get a negative answer, and 3 goes into 60 20 times. All right, so here comes the doozy. 8 times the quantity, t plus 2, minus 3 times the quantity, t minus 4, equals 6 times the quantity, t minus, I told you this was a doozy, t minus 7 plus 8. So we are going to do everything on that stinking card. That's our job today. We got one where we get to do it all, okay? Because we haven't done step 2 yet. We haven't had any combining like terms. So now, yeah, you're going to get it, all right? Wow, that took my whole screen. That's crazy. All right, so starting. I'm going to multiply everything in the first parentheses by 8. 8 times t, 8t. 8 times positive 2, positive 16. Then I'm going to multiply everything in the second parentheses by negative 3. So the sign is part of this. So a negative times a positive is a negative. 3 times t is 3t. Negative times a negative is a positive. 3 times 4 is 12. On the other side, I'm multiplying that group inside the parentheses by the 6. So 6 times the t, is 6t. And then 6 times the negative, signs are different, so I get a negative. And 6 times 7 is 42. And then we have this plus 8 on the outside. Okay, so here comes the big question. Do I have any like terms on this side? Yes, I do. So that's what I have to contend with. I have t's, so I'm going to put them side by side. And remember, I pick up the sign that goes with the term. If you need to draw those lines so that you see the sign that attaches, do that. Then I'm going to group the 16 and the 12. Okay? So basically, I've got 2 little mini problems I'm going to do. So what's 8t take away 3t? 5t. So I have 5t. And what's 16 plus 12?
28.
So I have a positive 28. So I got to get that sign in. Okay, let's look on the other side. Do I have any like terms on this side?
Yeah.
Yeah, what are the like terms on this one?
42.
Oh, they're already right next to each other, aren't they? So 6t has no friends. Sorry, buddy. And we have negative 42 and a positive 8. Okay, so when I do this one, I have equals. I get the 6t, nothing's happening to him, but now I need to take 42, negative 42 and 8. So what math am I going to do? Subtract. Is my answer going to be positive or negative? It's going to be a negative, so I put that in. And then this, since this one isn't as simple as the others, I'm just going to do my math off to the side, and I get 34. Now I've reduced it to no more than 2 terms per side, so that means I'm ready to solve. Okay, so what do you guys want to do next as your, you want to what? I don't have a 5. You want to subtract 5t? Okay. So that's going to give me 28 equals t minus 34. All right, now what? What could I do next?
Plus 34.
Yeah, if I took the t's to that side, I got to get the constants to the other side. So I'm going to add 34 to both sides. let's see, the signs were the same, so I'm going to add. I get a 12, 5 and 1 is 6. And I get 62 equals t, or t equals 62. So, worst case scenario, that's the hardest problem that you're going to deal with. If you take it in its bite-sized pieces, it's not so bad. So that's it.